Section 2.12 Bond Strength and Reaction Enthalpies. In any chemical reaction, some bonds are broken, some bonds are formed. When bonds are broken, energy is required. When bonds are formed, energy is released. So there's a way to estimate the reaction enthalpy given the bond strengths. For example, the bond enthalpy of hydrogen, chlorine, and HCl are 436, 242, and 431 kilojoule per mole. And then it takes this much energy to break the hydrogen bond, this much energy to break the chlorine bond. So energy must flow into the system. And then in the formation of the two HCl bonds, two of them, energy is released. How much? 2 times 431. Overall, the number is negative 184, so energy is released. The reaction enthalpy is negative. This is our prediction given the bond strength. This is the true value. They are pretty close to each other. So again, we have a way to estimate the reaction enthalpies just by looking at the bond strengths of the broken ones and the bond strengths of the newly formed chemical bonds. This is a table of the mean bond enthalpies. So hydrogen 436, carbon 412. The reason it says mean bond enthalpy is because the bond strengths between carbon and hydrogen is different in methane than in methanol, than in ethane, than in ethanol. So it's all different. But then it's just the average of many carbon-hydrogen bonds in many different molecules. And then this is the average nitrogen-hydrogen bond, nitrogen-carbon bond, nitrogen-nitrogen bond, and we have single bond, double bond, triple bond. Single bond, double bond, triple bond. Oxygen, same here. Between carbon and oxygen, you can have single bond, you can have double bond. Actually, in carbon monoxide, there's a triple bond. It's just not listed here. And fluorine halides, sulfur, phosphorus, silicon, and then this is I would say a matrix, the lower triangle of a matrix that show you the bond strengths between these elements and the same set of elements.